All right, so this should be our last video for calculus. This is really the last big part of the curriculum that you need to know how to do, and we'll give you a really good foundation for Calc 2. So let's go back and just kind of do a brief little review of what it means for integral, to take an integral, and what that means on a graph. So let's say I have a quadratic function, all right, and we'll make this real basic, x squared, all right, and let's say further that I wanted to find out what the area under that curve is, all right, and let's go from -2 to 2. All right, so I want to know what is the area under the curve. So that would give me all of this blue shaded area. All right, awesome. So let's say now, all right, so I'm going to erase this part. Let's say now that I want to know the area between two curves. Technically, what we just drew was the area between two curves. It's the area between x squared and the x-axis. All right, but let's be a little bit more fancy about this second function. And I am going to make it a linear function, like that. And I want to know what is the area, what is this purple area? The area between them. All right, well, I know that by using a regular area, I can find the area under the curve. All right, so I could find out the area under the linear function, and we're going to use the point of intersection because that's going to be between them. All right, so the area of this green, all right, is going to be all this, and it's going to include the purple. All right, so the area under the green function is the purple and the green shaded. All right, now if I wanted to find, or if I used integral to find the area under the curve between those 2 points, so between the curves of the parabola, well, that would give me all this. So not the purple, just that excess area underneath the parabola. So what that says is that if I want to find the area, that purple area, the area between the two curves, I'm going to take all the area from underneath the linear function and subtract out all the area from underneath the quadratic function. All right, and that is what we're going to look at for the next few minutes. All right, so area between two curves. You're going to take the integral of the top function, so the function that's above, and then you're going to subtract out the bottom function, the area that's underneath the lower function. All right, so for my first example here, and I know it's really hard to read, I've got a linear function that is x plus 1, and it's going from -1 to 2. All right, and then I've got this quadratic function. All right, and I want to know what's the area between them. So to set this up, I'm going to have to write really small here, the integral. And then I'm bounding them. I'm bounding them by where they intersect because I want the area between. So -1 to 2. And then I'm going to do top function minus the bottom function. All right, so top function is the linear, x plus 1, minus, and then I'm going to subtract out the function that's on the bottom, which is going to be this parabola. Let's see, it's x squared minus 1. gonna squeeze a dx in there. Maybe not. It's close enough. All right, and then we're gonna use this property right here to combine them into one integral. All right, so I'm gonna have the integral from -1 to 2 of x plus 1 minus, all right, I gotta distribute that minus sign now, x squared plus 1. All right, so now I'm ready to combine some like terms. So again, I'm going to change colors just because I'm squeezing so much. So -1 to 2 of negative x squared plus x plus 2 dx. All right, so now I'm ready to integrate. So -1/3 x cubed plus 1/2 x squared plus 2x. All right, and I'm going to evaluate that from -1 to 2. All right, for the lack of space that I have here, I am going to number crunch without showing it. So you could pause the video and do your number crunching by plugging in your 2 and then plugging in your -1. All right, so you could pause the video right now to do your number crunching. Okay, so at the end, after I plugged in my 2 and I plugged in my -1, I ended up with 9/2. All right, or 4.5 for that problem. All right, so that's the area between the two curves. All right, and we're going to do a couple of these problems together. For the first one, I'm going to set this up with you, and then I'm going to let you pause the video, do out all the work, and then I'm going to show you all of my work on the next page. All right, so find the area bounded by. All right, so I've got a parabola and a line. So I'm going to, just for give myself some more room, I'm going to erase. All right, there, now I can. Knowing your functions is going to be key here. And they don't have to be beautiful sketches. We don't need to be artists. There's my x squared and then my linear function. All right, so I'm going to have a y-intercept of 2 and a positive slope. So it should look something like that. There's my linear function. All right, now the first thing I want to find out here is I want to know where do they intersect. And we find out where two functions intersect, old school algebra one way, system of equations. So I'm going to take x squared and set it equal to x plus 2. X squared minus x minus 2 equals 0. Factor. All right, that's my intersection points. Those are the bounds on your integral. All right, so that's going to give me this right here is -1, and this right here is positive 2. All right, so integral from -1 to 2. From my drawing, I can tell that the linear function is on top. So I write that one down first, and then I subtract out the bottom function. All right, so what I'm going to have you do now is I want you to rewrite that in standard form. If you want, I kind of like things to be in standard form, but that's me. And then I want you to do the integrate into the integration and then the calculation. All right, so pause the video now. I'm going to turn to the next slide when you come back, and we'll continue on. So the next slide's going to have the answer. So pause the video now, do all the work, and then see if you get the same answer as me. Okay, so you might be thinking right now, hey Hurley, is the answer always 9/2? Because 100% of the problems that we've done so far have had an answer of 9/2. The answer is no. That just happens to be a coincidence that I probably shouldn't have had happen, but it's okay. what I really want to focus on now is setting these up because you guys have had plenty of practice in doing integrals. All right, so hopefully you got that question right, or if you didn't, you can look at my work and be able to figure out where you went wrong. All right, next problem. All right, so I'm going to set this one up with you, and then I'm going to let you do all the calculations on your own, especially because I run out of space. All right, and then I'll show you the answers. So find the area bounded by, so I've got this quadratic function, and it's bounded by the x-axis. So one important thing we need to remember here is that the x-axis is y is equal to 0, because that's our function we're going to use. All right, so you can tell by the graph on this one that the intersection points are -2 and 2, but you could have figured that out on your own by x squared minus 4 equals 0. You could have figured that out. So integral from -2 to 2, and my top function is 0, y equals 0, minus, and now I'm going to do my bottom function, x squared minus 4. All right, so distributive property. All right, gives me that. And what I'm going to do now is I'm going to have you pause the video, do out all of the integral calculation work, find that area, all right, and I'll move on in the next slide. All right, so you should have gotten an area of 32 over 3. Remember, it's area, so it's going to be positive. All right, and if you didn't, I've showed my work here, so you can pause the video and look and see where you might have had a little mistake. All righty, so what I'm going to have you do now is I want you to try these on your own, the setup, the calculation, everything just on your own, all right? And then when we come back, I'll show you the answers, and then we'll do a couple more, a little bit more trickster questions. We'll get away from the quadratic linear models here. All right, so go ahead, pause the video, try these problems on your own, set them up and everything, and when I come back, I'm going to show you the answers. All right, so here are the answers for those two problems. Hopefully you were successful. They definitely, some of the numbers got a little bit large in those fractions. Yeah, they're kind of a pain in the neck. If you got a cheat sheet, use a calculator, you do. But for the most part, I hope you're able to set these problems up on your own. Remember, doing the sketches of these are critical because it will help you find which function is the top function and which function is the bottom function, and can also help you maybe visualize what's going on a little bit better here. All right, so let's work on this next problem together, all right? It's sine and cosine. So the first thing I always want to do is I want to draw a picture. All right, and I'm going to do sine's going to be blue. And I'll put cosine as green. Again, being as accurate as I can be. And I want to find the area between these curves from 0 to pi over 4. So pi over 4 is actually where they intersect. Pi over 4 is going to be right here. All right, I know that they intersect there because on our table, cosine of pi over 4 and sine of pi over 4 are both equal to root 2 over 2. All right, So I'm finding the yellow area. So I'm going to set up my integral. And my bounds are going to be from 0 to pi over 4. And my top function here was green. It was cosine. And my bottom function here is the sine. Alrighty. So I'm going to integrate them. And when I integrate cosine, I get sine x. And when I integrate sine x, I get negative cosine x. So I'm going to change this to a positive of cosine x, evaluated from 0 to pi over 4. All right. Sine of pi over 4 plus cosine of pi over 4. I'm going to change colors here. Minus, I always put the minus stuff in parentheses so you remember to distribute that negative all the way through. Sine of 0 plus cosine of 0. Alrighty, sine of pi over 4, root 2 over 2 plus root 2 over 2 minus sine of 0 is 0, cosine of 0 is 1, so I'm going to have minus 1. Root 2 over 2 plus root 2 over 2 is 2 root 2's over 2. Cancel. Root 2 minus 1. Alrighty, so next problem. All right, I'm going to walk through this one with you as well because it's got some of our not traditional functions. All right, so first thing I'm going to do is draw a picture. Actually, I'm going to move this over so I have some space. All right, draw my picture. All right, e to the x. There we go. It is bounded by x is equal to -1. So we remember that x equals functions are vertical. So I'm going to draw x is equal to -1. Perfect. All right. And y is equal to 2. All right. So now you might be thinking, well, I don't know, is y equal to 2 below the intersection, above the intersection? One thing you should remember is that from pre-calculus and algebra 2, e to the x intersects at 0, 1. So y equals to 2 is going to be this line right here. All right. So to find the area between, I'm going to look for this green area right here. All right, so let's start to set up our integral and see what else we need to figure out. Got the integral, and my left bound is -1, and my right bound is, right here. I wonder what that could possibly be. If you remember from our quadratic linear functions, when we were finding their intersection, we set them up as a system of equations. So I need to figure out where they intersect. So I want to know, where does e to the x equal 2? All right, well, by taking the ln of both sides, I get x is equal to ln 2. So that gives me my top bound. All right, so that was just taking the ln of both sides. Alrighty, so now I need top function minus the bottom function. All right, and now I'm ready to integrate. All right, so I have 2 ln 2 minus e to the ln 2 minus 2 times -1 is -2 minus e to the -1. All right, I'm going to simplify this a little bit. 2 ln 2 minus cancels. 2 plus 2 plus, I can keep this e to the negative 1 or 1 over e. 2 ln 2 plus 1 over e is my answer. All right, so that is a pretty good detailed lesson on how to do these problems. The next problem that I have is a challenge problem. So if you would like to do this challenge problem, hint, it includes U substitution. All right, you can go ahead. If not, just let the video run and you can start working on your Delta Math when it's done. All right, so your next problem, the answers to the challenge problem are here. So you can take a picture with your phone or pause it or write it down or whatever you want. It's really exactly that. It's a challenge. Not something that I'm going to have you be doing in this last week of school. All right, so give your Delta Math a try. Reach out to me for any questions. If you want me to address anything, we can have a Google Meet on Wednesday, or individually, if you ever want one, we can do one one-on-one. Just let me know ahead of time so that I can clear my schedule. All right, I hope this video was helpful for you. Hopefully I didn't make any mistakes, which I don't think I did, and I hope you learned something. All right, have a great day, guys.